Alright, we're going to do some example problems where we have to use the efficiency formula. Efficiency equals 100U over T. So let's just jump right in here. So the first question says, if a light bulb uses 50,000 joules of electrical energy and emits 1,000 joules of light energy, what is the efficiency of the light bulb? So you're asked for efficiency here. Let's write down what we're given in the word problem. So the useful energy, the U, remember, is determined by by asking yourself, what's the purpose of the device? So the purpose of a light bulb is to produce energy. So when we look at the word problem, 1,000 joules of light energy is used to produce the light. So we're going to put 1,000 joules here for U. T is, well, what's coming out of the outlet? What's the total amount of energy, electrical energy, that's being used by the device? And you're told that that is 50,000 here. Okay. So this is a pretty straightforward problem. All you have to do is just substitute your values in here. So 100 times the useful, which is 1,000, and divide that by 50,000. And that, we plug that into our calculator, 100 times 1,000, and divide that by 50,000. That gives us an answer of 2. So our efficiency is 2%. And that's pretty standard for like an incandescent bulb, pretty low efficiency. Let's jump to the next question. It says, for most appliances, heat production is a wastage of energy that reduces the efficiency of the appliance. How much energy is wasted by a blender that is 60% efficient and uses 2,000 joules of electrical energy from the outlet? Okay, so again, you're asked for how much energy is wasted. Okay, so in order to figure out wasted, you have to know both the total and the useful. Okay, so let's continue here. You're told that the appliance is 60% efficient, so it's 60%. It uses 2,000 of joules of electrical energy from the outlet. So that's the total, so 2,000. Okay, and so we don't know the useful because we don't know how much energy actually being used to run the motor itself in order to turn the blades and mix the food. So this is a question mark for us. We're asked to find the useful. So what we have here in the middle is the algebra. Okay, so we want to figure out U. Now, so we have to isolate U all by itself on one side of the equation. So first we have to get rid of this T on the bottom. So if you multiply T here, then those two will cancel. We're dividing by T, so we have to do the opposite operation, right? So we multiply by T, and then what you do on one side of the equal sign or one side of the equation, you have to do on the other. So by multiplying by T over here, I have to multiply by T over here. These two cancel, and so we're left with efficiency times T and 100U. Then we have to get rid of this 100 here. So again, we're multiplying 100 by U. To get rid of it, we do the opposite operation. So we divide by 100. And again, what we have to do on one side, we do on the other. So if I divide by 100 here, I divide by 100 over there. The hundreds will cancel there, and I'm left with efficiency T over 100, which we have written right here, which is U. And of course, all we have to do is just flip that over to make it easier to write from left to right. So U equals the efficiency T over 100. So all we have to do now is just substitute those values in. And so efficiency is 60% multiplied by T, which is 2,000, and divide that by 100. Okay, and when we do that, 60 times 2,000, 60 times 2,000, and divide that by 100. That gives me 1,200. So there are 1,200 joules of energy that are actually used to power the motor. Okay, when 2,000 joules of energy are coming into the device. Okay, and let's jump to the next question. It says, how much electrical energy does a light bulb use if it is 5% efficient and produces 950 joules of energy? So again, the efficiency we're given it to be 5%. So let's write down what we're given. It produces 950 joules of light. So it's a light bulb. Its purpose is to produce light. Okay, so that 950 joules is going to be our useful energy. Okay, and we're asked to find the total, because it says here how much electrical energy does a light bulb use. So what's coming out of the outlet or the wiring in order to power that particular device. So again, we start with the efficiency formula. Sorry, and now we have to solve for T. Okay, we got to isolate T by itself on one side. So what do? Is we multiply both sides by T. Okay, and that brings T over to the left-hand side because they cancel on the right side. And now you're left with efficiency T. So if I divide efficiency T by efficiency, it cancels on that side. And of course, what you do on one side, you have to do on the other. So we'll divide by efficiency on that other side as well. And now, once the efficiencies cancel here, we're left with T equals 100U over efficiency. Now all we have to do is substitute. So 100 times the useful, which is 950, and divide that by 5%. 5. And when we plug that into our calculator, 100 times 950, and divide that by 5, that gives me 19,000 joules of energy that's coming out of the circuit in order to power that particular light bulb. Okay, and let's do the last question here. An electric kettle has a power rating of 1100 watts. It takes 4 minutes to heat 500 mils of water from 22 degrees to 100 degrees. If it takes 156,000 joules of energy to heat the water, what is the efficiency of the kettle? So what are you given here? You're given the power, which is 1100 watts. It takes 4 minutes, so you're given the time. Okay, and it takes 156,000 joules of energy to heat the water. So that's what a kettle does, right? Heat water. So that what we have here is the useful energy to heat the water, and now we just have to use the power formula and the efficiency formula. Okay, so again, when you're using the power formula, you cover up what you want to find. So we want to find the energy that's being used by the kettle total to do its job. And so we cover up E, and you're left with P times T. So energy equals P times T. Okay, and so it's 1100 times the time, which is 4 minutes. But again, we have to multiply that by 60 because the power formula uses seconds. Okay, so plug that into our calculator. 1100 times 4 times 60, and that gives me 264,000 joules. So this is the amount of energy that's coming out of the outlet to power the device, to heat the water, but also it includes its inefficiency as well. So we're asked to find the efficiency. So now we just have to substitute it in. So 100. We're told that the useful energy is 156,000 because that's what it actually takes to heat that amount of water. And we divide that by our answer from the power formula, 264,000, which is the amount of electrical energy that gets used. And then when we plug all that into our calculator, 156,000 times 100, and then divide that by 264,000, we get an efficiency of 59.1%. Okay, so this is a two-step problem. Figure out the electrical energy used by the device using the power formula, and then plug that in along with the useful energy you're given from the question to figure out the overall percentage of that particular device. Okay, so hopefully these examples help you with some of the board problems that you have to do for me. Okay, take care.